or also called, most of the time I refer to it as the cross product. The cross product is written like so: A cross B equals C. It's a cross, very clear cross. And I will tell you how I remember, that is method number 1. I'm going to teach you, just like with the dot product, 2 methods. I will tell you method number 1, which is the one that always works. It's time consuming, but it always works. You write down here a matrix with 3 rows. The first row is X roof, Y roof, Z roof. The second one is A of X, A of Y, A of Z. It's important, if A is here first, that second row must be A. And the third row is then B. B of X, B of Y, B of Z. So these 6 are numbers, and these are the unit vectors. I repeat this here, verbatim. You'll see in a minute why I need that. And I will do the same here. Okay, and now comes the recipe. You go from the upper left-hand corner to the one in this direction. You multiply them all 3, and that's a plus sign. So you get AY, so C, which is the A cross B, equals AY times BZ times the X roof. But I'm not going to put the X roof in yet, because I have to subtract this one, minus sign, which has AZBY. So it is minus AZBY, and that is in the direction X. The next one is this one, AZBX. Minus this one, AXBZ. In the direction Y. And last but not least, AXBY minus AYBX. In the direction of the unit vector Z. So this part here is what we call C of X. It's the X component of this vector. And this we can call C of Y, and this we can call C of Z. So you can also write that vector then that C equals C of X, X roof, plus C of Y, Y roof, plus C of Z, Z roof. It's the cross product of A and B. We will have lots of exercises, lots of chances you will have on assignment 2 to play with this a little bit. Now comes my method number 2. And method number 2 is, again, as we had with the dot product, is a geometrical method. Let me try to work on this board in between. If you know vector A, and you know vector B, and you know that the angle is theta, then the cross product C equals A cross B is the magnitude of A times the magnitude of B times the sine of theta, not the cosine of theta as we had before with the dot product. It is the sine of theta. So you can already immediately see that this will be 0 if theta is either 0 degrees or 180 degrees, whereas the dot product was 0 when the angle between them was 90 degrees. This number can be larger than 0. If the sine theta is larger than 0, it can also be smaller than 0. Now we only have the magnitude of the vector. And now comes the hardest part. What is the direction of the vector? And that is something that you have to engrave in your mind and not forget. The direction is found as follows. You take A, because it's first mentioned, and you rotate A over the shortest possible angle to B. If you had in your hand a corkscrew, and I will show that in a minute, then you turn the corkscrew as seen from your seats clockwise, and the corkscrew would go into the blackboard. And if the corkscrew goes into the blackboard, you will see the tail of the vector, and you will see a cross, little plus sign, and therefore we put that like so. A cross product is always perpendicular to both A and B. But it leaves you with two choices. It can either come out of the blackboard or it can go in the blackboard. And I just told you which convention to use. And I want to show that to you in a way that may appeal to ye more. This is what I have used before on my television help sessions that I've given at MIT. I have an apple, not an apple, this is a tomato. Not a tomato, it's a potato. I have a potato here, and here is a corkscrew. There's a corkscrew. I'm going to turn the corkscrew as seen from your side clockwise. And you'll see that the corkscrew goes into the potato in. That's the direction then of the vector. If we had B cross A, then you take B in your hands and you rotate it over the shortest angle to A. Now you have to rotate counterclockwise. And when you rotate counterclockwise, the corkscrew comes to you. There you go. And so the vector is now pointing in this direction. And if the vector is pointing towards you, then we would indicate that with a circle and a dot. In other words, for this vector, B cross A would have exactly the same magnitude, no difference, but it would be coming out of the blackboard. In other words, A cross B equals minus B cross A. Whereas A dot B is the same as B dot A. We will encounter cross products when we deal with torques and when we deal with angular momentum, which is not the easiest part.